Good evening, everyone. Uh, Good evening, everyone. Welcome to all of you for today's session. So I will first share my screen. Yes, I have shared my screen and my both camera audio is audible. Okay. So let's start today's session number 4. So welcome to all of you for this online and NPTEL course, that is MATLAB based programming lab in chemical engineering, and welcome all of you for the today's fourth session. So myself, Prasil Kapadia, I have completed my BTech from SVNIT Surat in 2019. Then I have worked in Reliance Industries Limited at Jamnagar for around 1 year, and I used their Aspen software. I learned there how to use it there. After that, I completed my masters from IIT Kharagpur. At IIT Kharagpur, I learned a similar course of this MATLAB course based taught by Professor Parag Deshpande. Currently, I am pursuing my PhD from IIT Bombay. This is my web page, and this is my LinkedIn ID, where you can follow me, and this is the YouTube channel where all the videos are uploaded. So let's get started with today's session with the problem statement of compressibility chart for carbon dioxide gas. So I will just switch off my video for a minute. Yes. So let me change the screen. Okay. So let's start with today's session. So for today's session, our main topic is compressibility factor that we will be solving using nonlinear equation. In last class, we took example of simple problem. Today we will be forming one compressibility factor chart. Just give me a minute. Okay. So when we start with compressibility factor, let me write it down. Compressibility factor. So the first question should be, what is compressibility factor? So compressibility factor is denoted by the symbol Z. The definition of compressibility factor is Z is equal to actual compressibility factor definition is ideal volume of gas. Sorry, compressibility factor definition is actual volume of gas divided by ideal volume of gas. So this basically shows how my compressibility, how my gas is fluctuating or how my gas is deviating from its ideal behavior. So let's say actual volume of gas is denoted by V, and ideal volume of the gas is denoted by V of ideal gas. So that I am using the symbol Ig. So V is equal to, what is the actual ideal volume of gas? Ideal volume of gas, it will be calculated by ideal gas law, that is RT divided by P. So my compressibility factor Z will be equal to PV by RT. Okay. So now the question is, what will be the value of Z? So for ideal gas, first, for ideal gas, what will be my value of Z? Z will be equal to V actual divided by V ideal. But my for ideal gas volume is ideal only. So my compressibility factor Z will be equal to 1. For real gas, Z is equal to V by V ideal. But V can be greater than V ideal, or V can be less than V ideal. So based on this condition, for real gas Z can be sorry, for the real gas, Z can be greater than 1 or Z can be less than 1. Okay. So here, one question comes like ideal gas volume. Ideal gas volume we can actually find by using ideal gas law, and we get P equal to RT by V. But the question is how to find real gas volume. Correct? So before that, what is ideal gas? When do we say that the gas is ideal? The gas is considered ideal when there are no intermolecular molecular interactions present. So this is the first condition when we say that the gas is ideal. And the second condition is the volume of gas, volume of gas molecule, volume of one single gas molecule is negligible in comparison with or in comparison to size of box. If these two criterias are fulfilled, we can say that gas is behaving like ideal gas. Just a minute. Yeah, okay. So in that case, we can say that gas is behaving like an ideal gas. But all the gases does not follow these two criteria. So what happened? The first equation of state for non-ideality, considering non-ideality of ideal gas was first introduced by Van der Waals. He added two parameters A and B. So what does A stands for? A considers intermolecular interactions between molecules, and B considers size of the molecule that we are neglecting. So if we introduce these two parameters, we can somewhat uh, come to reality. So our actual equation of state is P into V is equal to nRT, but Van der Waals equation of state is P plus A into N square by V square. That was the actual value. Then V minus NB, the volume of or the size of N molecules multiplied by B is equal to nRT. So this is nothing but Van der Waals equation of state. So for this Van der Waals equation of state, constant A is given by 27 by 64 R square TC square by PC, and B is given by RTC divided by 8 PC. So if we know these critical properties, PC is nothing but critical pressure. Correct? Just a minute. Yes. PC is nothing but critical pressure, and TC is nothing but critical temperature. Sorry. TC is nothing but critical temperature. If we know these two parameters, then we can actually calculate volume of any gas molecule at any given pressure and temperature. Okay. So after Van der Waals, there are various equation of states introduced. These are SRK equation of state, RK equation of state, SRK equation of state, Peng-Robinson equation of state. So these equation of states, these two equations of state requires one parameter, additional parameter called omega, and omega is nothing but eccentric factor that gives the sphericity of a molecule that we will not discuss right now because we are not going to use these three. We are going to today use Van der Waals equation of state to prepare one compressibility factor chart. So what is compressibility factor chart? So that is nothing but the chart of Z versus P. So uh, from this chart of Z versus P, just give me a minute. I want to, yeah. Yeah, this chart of Z versus P. So it follows like this with temperature. This is nothing but P is equal to 0. So we can see that when P is equal to 0, sorry, uh, wait, let me redraw this. This is Z versus P plot. This is Z is equal to, this one is, this P is equal to 0 point, and this is Z is equal to 1 point. So what happens? All curves start at, from 4p is equal to 0, all curves start at z is equal to 1. So what does this mean? This means that when there is a extremely low pressure or lower pressure systems, it will behave as ideal gas. Okay. And as pressure increases, you can see that um, deviation also increasing. See, but what happens when we are increasing, further increasing pressure after some point? So it is again going towards ideality. So what we say that gas behaves ideally at low pressure, one thing, and this point is one temperature T1, T2, T3, and T4. So gas behaves ideally at low pressure, and this T4 is greater than T3, greater than T2, greater than T1. So gas behaves ideally at low pressure and high temperature. So if there is high temperature condition, then also we say that gas behaves ideally, or there is low pressure condition, we can see that gas behaves ideally. So okay, so this is all about theory parts of showing how we can doing this theory of ideal gas and compressibility factor. So yes, so now let's move ahead with problem statement. So now it is clear that how we can calculate compressibility factor. So just give me a moment. I need to- Yeah. So now let's take this problem statement. I will first open this book. So here you can see this is the compressibility factor chart, that is Z versus P plot, and they have not written for which molecule it is. Yeah, this is for methane molecule. So for methane molecules, they have developed this chart. So let's do it for this molecule, carbon dioxide molecule at for, as we learn from this theory, we know that we need to find the pressure and temperature. We need to find the actual volume of the gas. We need to know the values of A and B, and A and B are dependent on TC and PC. So for CO2, critical temperature is given by 304.2 Kelvin, and critical pressure is 73.83 bar. So let's first do one thing. Let's try to find compressibility factor at one temperature and one pressure, and then let's do it for higher range. Okay, so I will open my MATLAB, and then we will go to, and then we will go towards complexity, where we will be actually preparing this kind of chart. So my MATLAB window is open. So let's start. Okay. So I will just open one live script. I don't want to save my codes because I have already written them and those are already saved. So let's write down one code. So from here, we can see that Z is nothing but ideal gas volume divided by actual gas volume. So I need to find actual gas of volume, and that can be calculated by solving this van der Waals equation. And for van der Waals equation, what do we need? We need input as pressure, temperature, R we know, N we will not bother right now. A and B also we know, 27 by 64 R square TC square by PC. So for that, TC and PC values are required. So we know we need to know all these values. And the major question is how to solve this van der Waals equation of state. So this thing we have already discussed in last class, that van der Waals equation of state, that is nothing but cubic equation of state. Cubic meaning it is in terms of big cube, three roots. So it will be having three roots, one liquid root, one vapor root, and one insignificant root. So this non-linear kind of equation that can be solved easily by using various numerical methods. This we have already discussed last class. We have last class we came across this bisection method, then we came across these methods of false position, then we came across Newton-Raphson method, and we widely use Newton-Raphson method. I will revise it quickly. So we'll not be using Newton-Raphson method, but we will be using MATLAB inbuilt command to solve this problem. So, but just for understanding, this is the Newton-Raphson method. This is the, let's say, this is your equation represented by a curve. So you are taking some initial gas at x is equal to x0, and for that value of x0, you are finding what is the value of your y0 or f of x0. Now from that point, you are drawing a tangent, and at whatever point it is intersecting on x-axis, from that point, you are again calculating the values of f of x1. From again that point you are drawing one tangent, and then you are taking your initial gas, and like that you are doing it until and unless you are reaching to your this x is equal to not x is equal to 0, f of x is equal to 0, your solution point. So this is Newton-Raphson method. Now in MATLAB, we really don't need to write the code for Newton-Raphson method. So what we need to do, we have some inbuilt MATLAB functions that we learned in last lecture. Those are roots command, f0 command, and fsolve command. So we will have one quick look in today's session, and then we will move to today's problem. So today's problem, we will not first preparing this complex chart. We will be just calculating compressibility factor at some particular pressure and temperature. So let's say, okay, so these are the good habits first to write clear all and CLC. Okay, so I want to calculate compressibility factor. So what I need to know, let's go to this equation. So from this equation, okay, first of all, let's define a universal gas constant R. So I am defining R in units of 83.14. So let's see from this book, when we take the value of R, just a minute. Yes, here it's given. So that TC and PC value, okay, let's first see value of R. I am taking in units of 83.14. So my uh, pressure should be in bar. My volume that I will be getting, it is in centimeter cube, and moles and Kelvin temperature will be always in Kelvin. So let's take P is equal to R is equal to 83.14. It's better to write down comments. What is the unit? Centimeter cube bar per mole Kelvin. Okay, so this is the unit of R. Then what do we need to define other than R in this equation? We need to define N. Let's forget N for now. Temperature we need to mention. So let's say I am guessing my temperature is equal to some 300 Kelvin, 300.15. The unit will be Kelvin. I'm just taking one random value of temperature, and let's say pressure is equal to, I am taking, what should I take? Let's say I'm taking value of pressure is equal to 4 bar. 4, I can't write 4 bar, right? So in comment, I will be writing the unit of pressure as bar. So Now I need to calculate, I need to know the values of TC and PC. So okay, here it is already given, but let's say you are not given the values of TC and PC. So what you can do from this James Smith book, you need to check Appendix B, that is for pure species, and you can search for carbon dioxide. So let's search for carbon dioxide. Where is that carbon dioxide? Yeah, here. Here is carbon dioxide. So I will just highlight it. And for carbon dioxide, 44 will be its molecular weight. Omega we don't need. Tc is 304.2 Kelvin. So it is the same exact value I have taken from here only. So Tc is equal to 304.2 in units of Kelvin. And it is Tc is nothing but critical temperature. Critical. It's a good habit to write it like this, so you won't get confused. TC and PC. What is the value of PC? PC is critical pressure. So from the book, if we check what is the value of PC is 73.83, 73.83 and units of bar. So my PC is 73.83 in units of bar, and it is nothing but critical pressure. Okay. So now what I need to find? I need to find these two quantities A and B. So A is given by A is equal to 27 divided by 64 into R square. So I can write it like R into R, or I can write R raised to 2. Whatever is fine for you, you can do that. R square TC. TC square R square TC square by PC, and I will put one semicolon at the end. So what will do semicolon? Can anyone tell me? What if I don't put semicolon? If we don't put semicolon at the end of the line, what will happen? It will print that value on the screen that we may not require. Okay, so we don't need to know the value of A. So I will be just putting one semicolon at the end of A. Now B is given by RTC divided by 8PC. Here we can see B is nothing but RTC divided by 8PC. So I will be writing B is equal to R into TC divided by 8 into PC. This is my value of B. Now I need to solve this equation of state, correct? So anyone remember how did we solve last time using F0 command? If someone wants to say. So we can use F0 command. Okay, let's see. I will show you our documentation again. F0 command. We are just getting familiar with this. So this is F0 command. So using F0 command, x is equal to F0. I write down function meaning equation and initial guess. Okay. So let's say this is my. Okay, let's take something. Yeah, see this x cube minus 2x minus 5. I need to solve it. So what I did, f0 is equal to function. I wrote this function, comma x0 initial guess. So my volume, let's first write down equation. So equation, I will be writing it as f is equal to at the rate of v, because my function is I am willing to solve the cubic equation. So what is cubic equation? Okay, let's do one thing. Let's try to simplify this equation. So how can we simplify it? So my equation is, let's for now take n is equal to 1. So P plus A by B square, V minus B is equal to RT. So I can write P plus A by V square is equal to RT divided by V minus B. Okay. So my equation will be PV square plus A is equal to V square RT divided by V minus B. So V minus B will be multiplied here. So PV cube minus PV square into B plus AV minus AB is equal to RT into V square. So my equation will be P into V cube. Here this 2 V square term minus PB plus RT into V square. Now V power 1 term AV minus AB is equal to 0. So this is nothing but this is a cubic equation and I need to solve this. Okay, let's again see this here. This equation, as it's a cubic equation, we will have three roots. Three roots, one will be liquid root VL and one will be vapor root. So it's obvious vapor volume will be much greater than liquid volume, and there will be third root that will be insignificant root. That is unstable root, so that volume we never observe. So we have two roots, liquid root and vapor root, and we want to solve for this vapor root. So let's write down this equation. You can even write your equation in this term also, but let's write down correctly in cubic term. So my equation is, okay. So my equation is P into, here from here if we see PV cube. So P into V cube, my first term. PV cube, my second term is PB plus RT minus P into B plus R into T into V square. Okay. My third term is A into V plus A into V, and my fourth term minus AB minus A into B. This is my equation of state. So let's do one thing. Let's keep one whole bracket for this equation. Now I need to solve this equation. So how can I solve this equation? So this equation will be solved as, let's say, my volume V. I guess V won't work. Okay, let's take V is equal to F0. What do I need to first write? Equation. So that is F. Okay, so here when I want to find the actual volume or actual vapor volume of a gas, so what should be my initial gas? What should I, what is the value of V from which I should start my, I should start or I should initiate? What should I, what should be the value of V I take? We are finding a vapor root. So what should we do? We should start with ideal gas volume, right? So let's say my initial gas is nothing but I am taking, writing it in bracket R into T divided by P. So this is nothing but my volume. So let's run this. So we'll be getting volume. So volume of gas is this value, 6.1353 into 10 raised to 3. If I write format long G, so it won't be showing in scientific, it will be showing like this, 6133.5 centimeter cube per mole. This is my actual volume. Now I want to find a compressibility factor. So what is my compressibility factor? Z is equal to this equation, correct? My compressibility factor is Z is equal to P into V by RT. So P into V divided by R into T. So let's see what is the value of compressibility factor I am getting. So I'm getting my value as 0.9831. That is near to 1, but that is not exactly 1. So we can see that gas is not actually behaving ideally. Let's try to reduce our pressure from 4 to 3 and see what is happening. It is 0.9874. See, let's do one thing. First 4, the value was 0.9831. Let's write it down here. T is equal to 4. My value of Z is nothing but 0.9831. 0.9831. Now let's further reduce our pressure to 3. So what are we getting as P is equal to 3? We are getting 0.9874. So it is going near to 1. Correct? Let's say I am taking P is equal to 2. So when I am dealing with P is equal to 2, it is 0.9916. See, at lower pressure, it is even going 0.9916. Okay. Let me write it down as P is equal to 1. So P is equal to 1, it is 0.9958. Okay. So this is atmospheric pressure. So atmospheric pressure, my Z is 0.995. Let's try to reduce P further. P is equal to, let's say it is 0.5. So at 0.5, it is 0.9979. Okay, P is equal to 0.5, Z is equal to 0.9979. So from here you can see that as pressure is going towards lower range, gas is behaving ideally. So if we further reduce it to zero point 0.1, see we are getting 0.999. Even 0.5 bar. This is extremely low pressure. So see, we can see that gas is behaving ideal gas at lower values of pressure. What other we observed when the pressure, okay, let me open that chapter. It's better to look it from here than my figure, the figure drawn by me. So one thing that we observed is any gas behaves ideally at low values of pressure, and that we have confirmed, correct? So where did that go? Yeah, here. So at low pressure, pressure tending to zero, gas is behaving ideally. It is correct. And what is the other case when gas is behaving ideally at very high values of temperature? So see here, see, you can see that values is not fluctuating from 1. For methane gas, so let's check the same thing for this CO2 gas. Let's keep pressure 4 again. Let's check it at 300. First, what was the value at 300 Kelvin? It was 0.9831. This was the value. Now let's increase from 300 to 400. So it is 0.9919. See, just increasing 100 Kelvin, it's not small difference, it's a huge difference but increasing temperature by 100 degrees Celsius, 100 Kelvin, value is changing from 0.98 to 0.99. Let's see if I'm going to 500 Kelvin. So see, that is 0.9956. At 600 Kelvin, 0.9975. At 700 Kelvin, 0.9986. At 800 Kelvin, 0.99927. 900 Kelvin. Are we getting any values greater than 1? I want to check that. 4000, it is 0.999. That is nothing but ideal gas only. See, the value is increasing. It is going greater than 1 for higher values of temperature. So see, as temperature is increasing, value is increasing from Z is going greater than 1. So what we confirm from here, gas behaves ideally at lower pressure and higher values of temperature. Okay. So now let's write down the code for, I am doing this thing manually, but let's do it by code. So I want to write a code that varies both pressures and temperature. Okay. So we will have to give some input of pressure and temperature. So let's remove this from here. So what I will do, let's first run a loop for temperature. So for T is equal to, what should we keep? Let's say I'm changing from 100 Kelvin to 1100 Kelvin in interval of 100. Let's right now keep higher value. Uh, let's first keep lower value and see what happens. So what we do, one temperature loop and one pressure loop. For P is equal to, let's say I am going from 1 to 1000. 1 to 1000 in interval of 10. So what will be I doing? I will be solving this equation of state. Correct? Now, and I will put two ends. Right? Okay. So now let's first run it and see what we are getting. So did we get any matrix for Z? No, we did not get any matrix for Z. We got just last value of temperature pressure combination of Z. But what do I need? I need to save these values of Z because I want to plot the value of Z versus Z against pressure. So what do I need to do when I need to save my data? Save my values. So what I will do, I need one, let's say I'm creating one matrix that is Z1, that is saving the values of Z. Z1 is nothing but Z1 colon Z. So what will happen? And initially I need to keep Z1 is equal to some null matrix. So what will happen initially for one temperature, my Z1 is initially a null matrix. Then what will happen for this one value of pressure, let's say P is equal to 1, it will calculate. I need to keep it after Z. Sorry. I need it will calculate values of compressibility factor. Then what will happen? My first value is 0 or blank and index, and then it is taking some value of Z. Now I have value of Z1 at first P is equal to 1. Now what will happen? My P is 1, then it will again go to this value. It will save. Then again go to this value, save. Again go to this value, save. And this loop will be ended for particular values of temperature. Correct? So let's first check if we are able to save the values of Z or not. So my Z1 matrix, okay, it's still running. Okay, it is not showing here. But when we, yeah, see, it is showing here 100 cross 1 matrix. Okay. But what happened here? It just saved for one temperature and whole pressure condition, but I need to plot it after every temperature. So what I will do now, I will, I will, I will place my plot function here only. So let's say plot, what is on my x-axis? On my x-axis from here, we can see days pressure, or what you can do. If you don't want to take pressure, you can also take reduced pressure, but let's do it. Pressure is on x-axis and compressibility factor Z1 is on y-axis. Okay, so let's just plot it for now. No, when do we need to plot? We need to plot it after one temperature and whole pressure combination. So what I will do, I will, after this loop is over and before ending that loop for particular temperature, let's plot it. And what we'll do, okay, let's plot it and learn what is the mistake that we will be doing. So let's say I'm running it. It's taking time. Plot will be shown here. Okay, let's do one thing. Let me keep one semicolon here because I really don't need value of Z at each point. So we'll put one semicolon and I will run it. Let's just wait. So see, there is no compressibility factor chart we were able to plot. So what happened? Why could not we plot it? Because we need to keep one function hold. Okay. So let's keep hold on command. So it will not end our loop. Let's wait. It should show in my let's do one thing. I don't know it's the issue with some live script. Control Z, sorry. Control C. I am keeping it, I am opening it as a new actual script. So it will be better. I am running it now. It will ask me to save it. So I will just save it and now it will run. Oh, then also it's not showing for whole values. So let's do one thing. Let's plot it for critical pressure, not with sorry, reduced pressure. So it is nothing but like this only, PR. So I will have to define what is my value of PR. So I will be plotting it against PR1. So my PR is nothing but P divided by PC. Okay. It should show, I don't know. Okay, yeah, I need to first define one blank. See, it is maybe because of pressure range. It was not showing. So when we use reduced pressure, we can see that there are okay here actually we can't give legend because there are hundreds of combination for temperature and pressure. So how this is how your compressibility factor chart. So see, if I zoom it here, there is no proper curvature here. Okay, so what we need to do, we need to increase or we need to reduce this step size. But as I will reduce my step size, my this code will be extremely slow. See, so it has improved. So this is how we can, so see, this is how we can plot our compressibility factor, and we can see that for all values, the curve starts at Z is equal to 1. And lower pressure, we can see that it behaves ideally. See till here also we can see that the gas is behaving ideally. Here it's ideal gas, then non-ideality is there, and then again it is going towards ideality. And here there are some lines that we can't actually differentiate right now. Those are ideal gas lines. So I hope this problem is clear. So this is how we can plot compressibility factor P versus Z. But now this is not a good representation of graph. So let's try to add axis. So how can we add axis? So we need to add title. So title is nothing but let's say compressibility factor chart for carbon dioxide gas. This is title. X label is nothing but reduced pressure. I'm just writing it as PR. Y label is nothing but TR. But I will not be showing how to. I will not be showing legend because there are hundreds of combination and legends won't work for this case. So when we do this, we can see that this is the simplified version. Let's say, let's try to do this for methane gas at these particular temperatures. So let's do it for methane gas. So my temperature is 175, 200, 225, 250, 300, 350, 500. So let's do it from 175 Kelvin. It is exactly 175 Kelvin in interval of 25 Kelvin. Let's do it till here 300 Kelvin, and let's see for these three temperature points are we getting exact answers or not. And their pressure is from till 200 bar, right? So let's also we also do it till 200 bar. But what we need to change, we need to change the values of TC and PC. So let's check the values of TC and PC. What is this page number? This is page number 39. So we'll remember it. So TC and PC from appendix B for methane. So for methane, C TC is equal to 190.6 Kelvin. So I will write TC is equal to 190.6 Kelvin and PC is equal to 45.99 bar. So let's see what we are getting for these three temperature points. Okay, so I'm running it. So see, it is well matching. Here actually they have not shown or they have not performed experiments for whole values of temperature. So see, for 175 it was at small value, but see at 200 Kelvin there is one sharp curvature near 50 bar. So let's see if we are getting it or not. Okay, here we have plotted it against PR. Let's do it against P. I don't want to plot it PR, not PRP. I'm not sure if it will work or not. No, it's not showing for PR because the range is huge. The range is huge. So that's why it's not showing. So let's do one thing. Let's keep PR1 only. So this is the plot at 200, 300. So you can see that near this value of PR, there is one sharp curvature. And as temperature is increasing, it is getting smoother and smoother. So let's check at 500 Kelvin. So for 500 Kelvin, let's do one thing. Let's go in interval of 100. I just want to check it what's happening at 500 Kelvin. So that will be our last line. It won't go, let's say 200. So see from here, it's one nearly a straight line and it's going up. So this is how we can plot compressibility factor chart. So what we learned how to plot compressibility chart using van der Waals equation of state. We learned this F0 function. We now learn these two new features that we need to give one null matrix when I am writing A is equal to blank. So it is not saving anything. But let's say when I write A is equal to A comma 1. So see, it is only saving 1. So that null matrix specifies that initially there is nothing, but we need that variable. So this is how we can plot compressibility factor chart. So I just want to take a minute of break. And then we will move ahead with the next problem of Jacobian of a matrix. So let's move ahead with the next concept of Jacobian of a matrix. So what is Jacobian? So Jacobian is nothing but you are having various okay. In Newton-Raphson method, we were only solving till now one equation. So we don't need any matrix, but let's say my equation is f is equal to x square plus y square, b is equal to f1 is equal to x square plus y square, f2 is equal to x into y. So for this kind of equation, how can we find the solution? Because there are two variables x and y. So for this kind of problems where we are having multiple variables with multiple functions, then or maybe only one variable but there are two functions, so in that kind of equation we need to solve Jacobian. More than one variable and more than one, obviously if there are more than one variable there will be more than one equations. So in that kind of condition we defined Jacobian of a matrix. So Jacobian of a matrix, consider a normed vector space x is equal to Rn and n cross 1 function vector means one row and all columns is defined as this is the function. So the Jacobian is defined as del f1 by del x1. So first equation 1 we are differentiating it with respect to all variables. Then equation 2 we are differentiating equation 2 with respect to all the variables. And then equation n we are differentiating it with respect to n variables. So let's just take one example here. Let's say my function f1 is equal to x square, x1 square plus 2x1 and my 2x2, let's say. And my f2 is equal to x2 square plus 2x1. And I want to find the Jacobian. So what I need to do, I need to calculate the derivative of function with respect to both the variables, like, right? So my del f1 by del x1 is equal to 2x1. Del f1 by del x2 will be equal to 2. Del f2 by del x1 will be equal to 2. Del f2 by del x2, first function with respect to all variables, then second function with respect to all variables will be equal to 2 into x2. Correct? And my Jacobian matrix is del f1 by del x1, del f2 by del x2, del f2 by del x1, del f2 by del x2. This is my Jacobian matrix. So how can we solve this Jacobian matrix in MATLAB? So I'm not saving this because I don't need it. So okay, let's first do all clear all and CLC. Okay. Okay, this is not going. I will just close it and I will take on new script. Yeah, it is working. So let's say my function 1 is equal to, but let's say I want to find my Jacobian at some particular value. Correct. So let's say my function 1 is x1 square plus, why did it go plus? 2 into x1, f2 is equal to x2 square plus 2 into x1. Here it's x2. Correct. Okay. So let's say I want to find a Jacobian. So what I will do, df1 with respect to equation 1 with respect to x1. So I'm writing df11. What is df11? 2 into x1. df12 is nothing but 2. Then df21 is nothing but 2 into x2. df22 is nothing but 2. And I can define my Jacobian matrix JA is equal to, J is calling Jacobian, is equal to df11 df12 colon df21 df22. So this is how I can show my Jacobian matrix. Okay, but it will not show it. Okay, so this is how we can calculate our Jacobian. But let's say I want to find my Jacobian at some particular values of x1 and x2. Let's say my x1 is equal to 2, x2 is equal to 4. I want to find it at this point. Okay, no, but it will not take it like that. Okay, so we will be writing one function and then we will be seeing how we can calculate Jacobian. Just give me a minute. I'll stop sharing my screen. Okay, so let's do one thing. Now I want to find my Jacobian at particular value. So what I will do, I will write down my one function. So what I can do, I can just define my function in terms of x is equal to x1, x2. Okay, and here writing x1, we can write x of 1. We'll be needing one dot here and x of, sorry, x of 2. Similarly here also x of 1. This is just for finding Jacobian at some particular values. Similarly here x of 1 and x of, okay, so we'll remove it. Let's say I'm giving function Jacob is equal to my Jacob, and I will be writing in bracket x. I am calculating Jacobian. I'm writing, I should write Jacob. Okay, let's say I am calculating my Jacobian at my x is equal to, let's say, I'll be putting one and here. Okay. So let's say I want to find Jacobian at x is equal to, this is my vector x is 1 comma 2, and I want to find Jacob. So I will be calling my function Jacob comma x for particular x. So it will calculate Jacobian. So let's see what we are getting Jacobian. Say I am getting 2 2 4 2. Is that the correct answer? My Jacobian is 2 into x1. x1 is 1 2 2 then 4 2. So this is how we can calculate Jacobian writing one function. This is currently it is seeming that this is useless, but this is a really important concept in numerical methods. So let's do one thing. Let's calculate the Jacobian of this function ax1 square minus bx2 x3 e raised to x1 and this whole matrix. So let's write it down. So let's say I am calculating it as at minus 1 2 4 and I will be calling the function. Now what is my function? My function is a into x1 square. Let's define my constants earlier. I'm giving some random values. Let's say a is equal to 4, b is equal to 2, then c is equal to minus 3, d is equal to, let's say it is 3 by 2, and e is equal to minus 5. Let's say these are my some random numbers of a, b, c, d, and e. So my function f1 is equal to, okay, so one thing, do we need to find f1, f2, f3? We don't need to find, we just need their differentials. So I will be removing this F1, F2, because we really don't need it. So what is my F1 with respect to derivative of F1 with respect to X1? So it is 2a X1 minus this whole term e raised to X1 is just e raised to X1. So this 2a X1 minus this same thing. So it is nothing but 2 into a into x of 1 minus same thing b into x of 2 into x of 3 same term into exponent of x of 1. Okay, so this is my df11. Now derivative of f1 with respect to x2, that is nothing but minus b x3 exponent of x1. So I will be just writing, I will copy it from here, I don't want to write it again. It is nothing but minus b x3 exponent of x1. And similarly, my last term will be minus b x2 exponent of x1. Okay, so this is my first row. Now I will be derivating my second equation with respect to first variable. So this equation. So with respect to x1, it is just 2c x1. I will be writing 2 into c into x of 1. Then my df22 second equation, it will be 2d x2 plus this x3 square sin x2's derivative is cos x2. Correct? So I'll be writing 2 into d into x of 2 plus x of 3 square into cos of x of 2. And my df33 will be equal to third derivative. So x3 is just here only, so it will be 2x3 sine x2. So 2 into x of 3 into sine of x of 2. Be really careful while writing this question. Okay, so this is my df33. Now I am to find third equation, correct? So df31, third equation with respect to first variable, it is nothing but x2 square plus this whole term, correct? So it is x of 2 square plus this whole term. No, it's not plus, it's no, here also there is one x1. So derivative of cos is minus sign. So it will be minus e into x2 e into x of 2 into x of 3 square into sine of x of 1. Okay, so this is my df31. df32 is equal to second with respect to 2. So it is 2x1 x2 plus e x3 square cos x1. So I'll be writing 2 into x1 into x2 plus that last term e into with respect to x2. So this x2 term is 1. So it is x3 into cosine of x of 1. Okay. And my third derivative with respect to 3. So it is just 3 term 2e x2 x3 cos x1. So I will be just copying it from here. I will modify it. It is nothing but 2 into E into x2 into x3. Okay, so this is my, now I need to define my Jacobian df1, 1, 2, 1, 3. Then similarly 2, 2, 2, 3. Okay, so let's run it and let's see what we are getting. Are we getting any Jacobian matrix? df11, df12. Okay, here it should be 2, 3. So I am getting any matrix. Yes, I am getting Jacobian 3 cross 3 matrix like this. So this is how we can find Jacobian of a matrix. Let's say I'm changing my input to 0, 0, 0, 0. It should be all 0. Correct? For 1, 1, 1. It won't be 1, obviously, but it will be some value. Okay. So this is how we can, this is how we can calculate Jacobian of a matrix. So now let's take previous year's assignment question and solve. Let's try to solve these multiple simultaneous equations. Okay, and nonlinear equations most importantly. So let's do that. I will open that question bank. Sorry, this needs to go. Okay, let me first stop sharing it here. Let's start this from question number 1. This is last year's 23/8/2023 previous year's assignment. Let me share my screen again. Okay. So this is the first question. It is saying that find the solutions of the systems of nonlinear equations with the initial guesses x1, x2 is equal to 2, 3 using fsolve function in MATLAB. 3x1 minus x2 is equal to 2. 2x1 square minus x2 is equal to 0. Okay. So let's do it here. I don't need to save this, so I will not save it. So I am supposed to use f0, fsolve function, not f0. Okay. So just give me a minute. Okay. So what I need to do, I am having equation. So like the previous problem, we have two ways of solving it. Okay, let's check it using both the ways. These are the same questions I have copied here. So I will be closing it for now. Okay, so the first question is this. X3x1 minus x2 is equal to 2, 2x1 square minus x2 is equal to 0. So I will define f is equal to, at the rate I have two variable, right? x1 comma x2. Then I will be writing my two equations one by one. That is 3x1 minus x2 minus 2, 3 into x1 into x2 minus 2. This is my first equation. And my second equation is 2x1 square minus x2 is equal to 0. 2 into x1 square minus x2. Okay, so these are my two equations. Sorry. I guess I need to use this one. Yeah, this is yeah, it's multiple equations, so I need to use this bracket. Yeah, so my function is written. Now I will use xsolve. So say my xsolve is equal to at the rate using fsolve, f solve solving f with initial gas of, let's say, what is told, are we told an initial gas 2 and 3, so 2 comma 3. Let's see. Again it's showing invalid expression. Okay, now you, there is no fsolve. Okay, there is no at the rate at fsolve. Okay, so what it is showing, not enough arguments. Okay, so we can't actually, when we are having multiple equations, we need to form it in terms of 1x, and we need to define it like x of 1, like that, x of 1, x of 2, like that we need to define it. It won't work. Okay, now, so see, it's showing that equation solved, and I am getting my solution as 0.7 and 0.96. So I am getting any answers of 0.7? No, there is no answer. So answer is here is, no, it's saying no solution, and we are not getting no solution. 3x1 into x2 minus 2 into x1 square minus x2. Okay, I need to wait. This is not our solution. As we are dealing with vectors, we need to put this dot sign. Yeah, it is showing equation solved. Yeah, okay, it is 3x1 minus x2. That's why. Okay, 3 into x1, that's why it is showing equation solved. Wait. Yeah, okay, I typed wrong equation. I'm sorry for that. 3, 3x1 minus x2. Okay, now it should show me the no solutions. Oh, okay. So there is no solution, and the solution stops at here. So that doesn't mean that this is the solution, but our loop stopped at here. So here it is written that no solutions found. So there is no solution available for this particular problem in interval 2 to 3. We can check for some other interval, but I'm not sure if solution is there or not. No, no solution found. No solutions found. Okay, so this is not a solvable system. So answer should be no solution. So answer should be D. Okay, next problem. Find the intersection of a circle and a line described by the following set of nonlinear equations with the initial gases in the range x1 0.5 to 1 and x2 0 to 1. So the common solution, let's do it. X1 square plus x2 square is equal to 5. That is nothing but equation of a circle. Guys, just give me a minute. I need to start charging my laptop. Okay. Okay, so let's try to solve this equation. So I will just do one here all CLC. So can we do one thing? Okay, let's first solve it using this way. So I need to write my f is equal to at the rate of x. Then in bracket, as it's a matrix, I need to use a square matrix, square bracket. My solution is, equation is x1 square plus x2 square minus 5. So let me write x of 1 square plus x of 2 square minus 5. This is my first equation. I will put one semicolon and I will write down my second equation. X2 minus 3x1 plus 5. X2 minus 3 into x of 1 minus 5. This is my equation number 2. So I will press on enter. So my equations are stored. Now what I want to do, I want to find a solution. So let's say x solve is equal to using, are we told f solve? Using f solve of f comma, I need to write down my initial guess. So what is my initial guess? My initial guess is x1 should be from 0.5 to 1 and x2 should be from 0 to 1. Okay, so let's find one common point, that is 0.5. So let's take 0.54 x1, 0.54 x2. This means that my value of x1 should be from 0.5 and 1, and x2 should be from 0 and 1. We can even do that. Let's take 0 and I will press enter. So see, my solution is, one solution is showing me as -1 and 2. Is -1 and 2 in our options? No, we can't see -1 and 2. So we need to change our initial guess. So let's keep 1 1. 1 1 is also giving me the same solution, -1 and 2. But my x1 should be from 0.5 to 1. So let's do one thing, 0.5. So again, it is showing same solution. Let's take 0.5, 0.5. Okay, it is showing the same solution. Wait, let me check if I have written equation correctly. X1 square plus x2 square minus 5. Okay, yeah, here it should be plus symbol. I'm sorry. And let's go with our first initial guess. So see, we are getting the solution of 2 comma 1. Let's check if we are getting with 2 comma 1. 2 square 4. Answer is 2 comma 1. Okay, so 2 square 1 plus 1 square 1. So it is 5. 2 comma 1. Sorry, 2 comma 1. So 1 minus 6 is minus 5. So this is our solution. Okay. Let's try to see if it is solvable using F0. I'm not sure if F0 will work or not. No, F0 can't work with multiple functions. Okay. So we need to compulsorily use fsolve command. So this is how we can solve this equation using fsolve command. Now let's go to next equation. Last year assignment problem, question number 3. For the solution of systems of nonlinear equations numerically, it is important to determine the Jacobian of a vector function, which is the matrix of partial derivatives of that vector function. Determine the Jacobian of the following vector function using Jacobian inbuilt function. Okay, we checked this using we learned how to solve these using uh, new manually. So let's first try to find out what should be the answer. Let me start my presentation. Just wait a minute. Yeah. So see how we can find a Jacobian. So we learn from here. I need to first derivative my function of first function with respect to all x1, x2, x3. Second function with respect to all x1, x2, x3. So from here we can see that what will be my df1. Okay, let me write it down. And so f is equal to x square plus y square, and second is x square into y square. Okay, x square y square. So first del f1 by del x1 will be equal to, or del x will be equal to 2x. Del f by del y will be equal to 2y. Then del f by del f2 by del x equal to 2x y square, and similarly del f2 by del y is equal to 2x y 2x square y. So this is what we should get as answer, that is 2x. Okay, options were here: 2x 2y 2x y square and 2y x square. Should get correctly as answer C. But what we are told, we are told to use inbuilt command Jacobian in MATLAB. So we know the theory, but let's see how we can, okay, how we can do it using MATLAB inbuilt function. So okay, so what we are doing, we are dealing currently with symbols of x comma y. So I need to call my symbol function SYMS symbol toolbox x comma y. Okay, okay, I have called it. Now I will be writing my equation. F is equal to, first is x square. Here you need to be really careful with what we say, with row comma column. So we are told it like x square y square and there is one colon. Okay, it is not in one row. It is in, yeah, it is in first row then second row. So I need to put one semicolon. Let's say if I don't put semicolon, what happens? Square. Okay, I have called is x square comma y square. Okay. Oh yeah, it should be this bracket. Okay, I have written my function. Now what is told to me, I'm supposed to use Jacobian inbuilt function. So let me go to this MATLAB manual, this function. Let's search Jacobian. How do it find? What do we need to write to find Jacobian? So we can see that, see, I need to find Jacobian function comma v. So I am just writing f comma. Let's just write Jacobian comma function. First, let's do that. Jacobian of my function. So it is giving me exact answer: 2x, 2y, 2x, y square, 2x square, y. Okay. But let's say I wrote it down like this. I did not put one semicolon here. So let's see what we will get. I'm sorry. Wait a minute. Here it is square matrix. So here let's say I am removed semicolon from here. And now I want to find Jacobian. Okay, it is the same answer because it's just one row. It's not affecting. Okay, now let's say I want to find Jacobian at some particular values. I don't know if it will work or not, but let's try. No, it won't work like that. Where did that help manual go? Okay, so this is just simply we can find Jacobian. Okay, like this. Yeah. So this is how we can calculate Jacobian of a function. So see these complex equations. These also you can directly find Jacobian of those complex equations. You can directly find using Jacobian command. Okay. Let me try one thing. Let's say x is equal to 1, y is equal to 2, and I am finding this won't work like this. Okay, let me do one thing. J is equal to Jacobian of f. It won't work like that actually, but let's try it. We can't mix up symbol tools and this. And then let's say I'm taking my x is equal to this, y is equal to this, and let's say what is the value of j. No, it won't show. So it will just as our symbol tool is there. We can't actually find. We need to do it separately. 2x, 2y, and this thing. So okay, so this was the small exercise for calculating Jacobian of a matrix. Now let's move ahead. Consider the following set of equations which is solved using fsolve in MATLAB with initial guess of three unknown variables 0, 0, 0. three equations are there and I need to find a solution. So let's try it. Let me first do this clear all CLC. Okay. So what I will be doing, I will be first writing down the equations. So sorry. Hmm. Plus x of 3. Okay, this is my first equation. Zero point 0.65 into sine of x1 plus second equation, then third equation by putting one semicolon. And I need to close this equation bracket. Okay. Now what is told to me? I need to find my solution at 0, 0, 0. So my x solution is equal to, what do I need to use? fsolve. Then my function f comma vector 0, 0. Okay, so see, I'm getting my solution at minus 0.26377. Okay, let me do one thing. I don't need this whole long digits. So see, only up to 5 digit, it is showing me the answer minus 0.26377.4025 and minus 0.058256. Let's say I'm changing my initial guess to some random value. Then also it is giving me the same answer. Yeah, it is showing me the same answer. Let's go till negative. So this is the only one solution that we will get. Okay. So this is how we can use fsolve command for nonlinear. Let's say I want to find the Jacobian of this. So how can I find Jacobian? So let me do one thing. I can copy this matrix, right? Okay, but okay, first I will need to call symbol tool. Okay, let's do that. Of x comma x1 comma x2 comma x3. Okay, not symbol, sorry. What is that? SYMS, not symbol. SYMS. Okay, now let's call this thing. I need to write x1, x2, x3 term, and let's see what is the value of Jacobian that I am getting. If I am doing it on pen and paper, it will be really a tedious task. Okay, so I have written my function and I'm calculating Jacobian of this function f. So see, this is the Jacobian that we are getting. If I am doing it on pen and paper, I will get the same answer. It won't change. Okay, now let's move ahead with the next problem. Consider the following set of equations solved using MATLAB with initial guess of 0, 0. Okay, so let's do it. X1 cube. Okay, so my f is equal to at the rate of x. Then I will put one square bracket because it's a matrix. X1 cube, x of 1 cube, x1 cube minus 2.5 x2 square minus 2.5 into x2 square plus 4 into x1 minus 3.7. Okay, so this is nothing but my first equation. Okay, my second equation is 0.7 x2 square into square plus 3x2 plus, be really careful while typing equation, 3 into x2, x of 2, x of 2 minus 1.8 into x of 1 plus 1. So these are my two equations. Now I need to solve these two equations using fsolve command. So I'll be writing fsolve is equal to fsolve my equation f, comma, initial guess is told to us as 0, 0. It is showing me some. Okay, there is some mistake. Wait a minute here. We have only two values of x1 and x2, correct? Yeah, okay. The error is because of as we are dealing with matrix. Sorry, it won't work. As we are dealing with matrix, we need to use this dot symbol. It's not working. I don't know why. Okay, there is some typo error. This is x1 cube. I have written it correctly, right? F of x, x1 cube minus 2.5 x2 square. Okay, here it should be dot 2 plus 4 into x1 minus 3.7. Then second equation 0.7 into x of 2 square. Here also 1 dot plus 3 into x2 minus 1.8 into x1 plus 1. Now it should be correct. I don't know why it's showing error because equation
We have written it correctly. What is the error that it's showing? Dimensions of arrays. The issue is with dimensions of arrays. Why? Is correct. So 1, this is correct. Issue is here somewhere. I'm not understanding what is the error, but everything that we have entered is correct. I don't know if someone can point it out. It is correct. X1 cube minus 2.5 x2 square. Let's try to remove this, but it won't help actually. Yeah, now it's showing the solution 0.85 and 0.14. It's no solutions found. Even it's showing no solutions found. Okay, it is showing no solutions found. X1 cube minus 2.5 x2 square plus 4x1 minus 3.7. This is my first equation. My second equation is 0.7 into x2 square plus 3 into x2 minus 1.8 into x1 plus 1. I don't know. It's correct actually. I don't know why it's not showing any solution. Yeah, it's not showing any solution. Okay. So this was problem 5. Now let's move at problem 6. This. Find a solution of this linear system x1 minus 2 whole square plus x2 minus 2 whole square equal to 9. And this thing. Okay. So let's do it here. X1 minus 2 whole square, x of 1 minus 2 whole square plus x of 2 minus 2 whole square minus 9. This is my first equation. My second equation is x1. Okay, let me copy this. I just need to change that constants. My second equation is x1 plus 3 whole square, x2 plus 1. Okay, so these are my two equations. I need to close this bracket. Okay, so these are my equation. Now we are supposed to solve this at 0.35, 0.6. 0.35, 0.6. I guess we will not find a solution. Yeah, it's solved. Minus 0.1362 and minus 0.1063. See, we are getting exact answer. So, but what happened to the previous problem? Let me try it again. X1 cube. Let's retype the equation again. X1 raised to 3 minus 2.5 into x2 square plus 4 into x of 1 minus 3.7. This is my first equation. My second equation is 0.7 into x2 square plus 3 into x2 minus 1.8 into x1 plus 1. Okay, and I was supposed to find it 0, 0, I guess. See, now it's showing the solution. I don't know why earlier it didn't show me the solution. So this is the same equation that we wrote. Okay, I just want to check if we wrote it same or not. Yeah, we wrote the same equation. I don't know why at that time it didn't solve before even putting these dots. So this is my equation. It is the same as this one. Yeah, I don't know why what we made the mistake last time, but this is what we wrote recently and it is showing me the correct solution 0.80694 and 0.1455. There may be some typo error that at least I am not able to figure out right now. Okay, now let's move on for the next problem. 7. Some problem here. Xy is equal to 4 and x square by 4 plus y square by 25 is equal to 1. Okay, so can we solve this in some other way? Let's say x is equal to x is starting from 0 to 1 to 2, right? So let's say 1 colon 0.1 colon 2. I'm plotting it actually. Y is equal to 0 to 2, I guess. 0 colon 0.1 colon 2. Right? My f1 is equal to x into y into y. Here I need to put one dot because we are dealing with scalar. Ah, okay, it should be of same size. X and y. Yeah, it should be of same size. Okay. So let's do one thing. Both 0 to 2. Okay, let's keep both to 0 to 2. Dot. And f2 is equal to x square by 4 plus y raised to 2 divided by 25 minus 1. Here also we need to put colon here. Dot here, not colon, sorry. Let's plot f1 comma f2. No, we should not plot f1 comma f2. We should plot first x axis, let's say x, y axis f1, put hold on, and again with f2. Yeah, it's showing it with x. So actually I am not seeing xy is equal to 4. Yeah, okay, my equation is xy is equal to 4. So okay, I will have to rewrite xy minus 4. My f2 is, sorry, xy is equal to 4. Now let's plot first f1. Wait. Let me clear on CLC. It's mess. So see, let's first x1 f1 is equal to, let's first define the range of x comma y. X same range y. Then I will write my function f1. Then my function f2. Then I will first plot x1. Now I will put hold in, not hold on. Then x2. So see, they are intersecting somewhere after 2. Okay, we can't see actually from here. Let me do one thing again. Okay, so this is how from here it is intersecting somewhere after this. Let me do this thing. Are we getting it? Yeah, it is somewhere after that. So let's do it using let's doing using fsolve command. So my f is equal to at the rate of x into y, xy minus 4. So x of 1 into x of 2 minus 4. My first equation, second equation, x square by 4 x1 square divided by 4 plus, no, I was not supposed to press enter. With x1 square by 4, yeah, x1 square by 4 plus x2 y square by 25 minus 1. So these are my two equations, and I am supposed to solve it at between 0 comma 0 to 2. Let's give 1 as initial solution. X solve equal to f solve f comma 1 1. Let's give 1 1. I don't know if it will work or not. No, it's not. It's again some typo error. Let's do one thing. It's some typo error. No, it's not working. I guess it's some typo error right now. I can't find out. It's not with dot. No, it is some typo error. It is 1 comma 1, right? Okay, let's do one thing like this. It is no solution, but there is one solution. We know. Okay, I don't know. It is some typo error that I am not able to find out right now. But this is how we can solve it. Okay, next question. Back mixing can occur only in which kind of process? Back mixing, it's not going to happen in stagnant reactors, right? It will only happen when there is a flow in the reactor. So the correct answer is in flow reactors. Which of the following reactors supports high degree of mixing in all direction? When when do we see mixing? It's not going to happen in longitudinal, right? Because there will be only longitudinal mixing. So it will be in stirred reactor because there will be one continuously stirring. So because of stirring, there will be high degree of mixing in all direction. The unit of space velocity, the time to require one process one reactor volume, that is second inverse. The unit of space velocity is second inverse. Okay. On generating three density plot to examine the effect of jacket temperature and space velocity on the steady state temperature in the diabetics continuous stir tank reactor, it is observed that with increase in space velocity, we move from monotonic to multiple steady state. There are, I guess, three steady states. This is a classic example of cusp catastrophe. So this is a true, because when there is this statement is true when we are moving from monotonic to multiple steady state. Then next question. Okay, again, we are supposed to solve this equation. So let's solve it, but let's be really careful. X square plus y square minus 1. My first equation. My second equation is, sorry, my second is x 2x square minus 2. Okay, it's not 2 into y, 2 into x of 2. Sorry. Yeah, okay, here it should be this. Hmm. Now I am solving it. So I will be writing x is equal to f solve of x f comma my initial solution. What is my initial solution? Initial guess, let's say 0.5, 0.5. I don't know if it will work or not. So I'm getting my solution. Yeah, it's working. 0.0004, comma 1. Is this the correct answer? Yeah, it is the correct answer. 0.0004, comma 1. We can take some another initial guess also. 1, comma 0. 1, comma 0 is also one solution. Okay, let's see if 1, comma 0 is solution. 1, comma 0 is also a solution, comma 0. Yeah, I just put some random values. I was not doing if it will work. 0, comma 1 is also a solution. See, 0, comma 1, 0, comma 1 is also a solution. Okay, let's give some huge values. 4, comma 0. So it's giving 1, comma 0. Okay, so this is how we can find multiple solutions. Okay, next one. What is the purpose of figure command? Why do we use figure command? Okay, I will show you the example. Okay, so okay, let's take this example using figure command. Let's say my x is starting from 0, comma 0 to 0.1 to 1. My y is equal to same 0, comma 0.1 or 1. Okay, this is my x and y. My function f1 is equal to x square plus y square minus 1. X square plus y square. It should be here, not here. Minus 1. My f2 is equal to, what was the f2? 2x square, 2 into x square plus 2 into y minus 2. Okay. Let's say I want to plot x comma f1. Okay, it has plotted. Now I'm putting hold on command and I'm plotting x comma f2. Okay, so we can see that both the plots are in 1 point. So see here, from here you can see that there is one solution here. Okay, but let's say I want to see two different figures at the same point. So what can I do? What can I do? Okay, let me copy this code here. Control C, new live script, Control V. Okay, so let's say what I want to do. I want to have two separate figures. So I will write figure one. I won't put hold on command and I will put figure 2. So what will happen? Let's see. So see, two different sets of figures are represented in front of us with two different functions. So what is the use of figure command? That opens a blank window to write scripts, opens a blank window to draw graphs to containing axis or containing grid and axis. It's a opens a blank window and it will draw different graphs. So answer is B. One or two questions are only left. Let's 19. What is the color code for color black while plotting in MATLAB? So plot color code for black it is K, but let's see for other also. I have searched it. Okay. So here plot color code is there. Yeah. See, for red it is R, for green it is G, for blue it is B, for cyan it is C, magenta M, yellow Y, black K, and white W. So for black it is K. So right answer is option C. Next question, the EZ polar command is presented in, it is in symbolic math toolbox. If we search EZ polar, so see it is dealing with theta. Just for this example, theta square. So in 2024 it is not recommended, but it falls under C, it is symbolic tools, T, cos T like that. So this either polar falls under symbolic symbolic tool, symbolic math toolbox. The correct answer is option A, symbolic math tool. Okay, so this is all about today's lectures. In today's lecture, we learned how we can plot compressibility factor chart. Then we learned fsolve command for various coupled nonlinear linear kind of equations, and then we took some of the small problems. So this is all for today's lecture from my side. Thank you for joining, and if you are having any query, please feel free to write me on this email ID. I will try to resolve it. If it's regarding to assignment or anything, feel free to write me. Yes, I will wait for 1 or 2 minutes. If someone has any doubt, you can write me here in chat box, or you can ask me.
Hello,
Hello, yes.
sir. One times, one times repeat the function of as polar, please, sir.
Sorry, you are not clearly audible. Can you repeat? Hello? EZ polar, you are
Okay,
asking something about EZ
okay.
polar? See, okay, let's take this example of for EZ polar. I'm taking this EZ polar. So, okay, let me close this. I don't need it. Okay. So, see, this EZ polar. So what we did, we are using some theta thing. So this theta, we are not saying it. Okay, let me write it down as x. Sorry. So it is taking x as some kind of symbol and it is running it. So if in your MATLAB command, in your MATLAB code, if there is symbolic toolbox is not installed, you can't actually plot this kind of thing by directly putting these symbols x comma theta. So this ez polar is used when we are dealing. So for that, that command is present in this symbolic math toolbox. The way we did in that problem symbols SYMX, it is presented by SYMSX. So we need to write it, and when we find Jacobian, we use this kind of symbolic toolbox. So this is polar falls under this. You can plot anything. Let's say cos square x. It's not. Okay, command cannot plot cos of more than one variable. Okay, so I can't plot. I can plot, I guess, cos. And I need to write it like this: cos into 2x. It only put one variable at a time. 2 into x. I guess I need to write. Yeah. So this is how it works. This blue thing is, you can see, that is actual curve of cos 2x. Okay, so the main question was, where does this EZ polar falls on? So it is under symbolic toolbox because it is dealing with symbols like x, y, z, theta, gamma, anything we can give. Okay, anything else? If you have any query, you can you feel free to write me here. Thank you everyone for joining. We will meet next week. Thank you so much. Till then, enjoy and take care. Bye bye.